Hi everyone, it's Brant. I'm back for our lab on security today. Now this is arguably I know I feel like I probably say this every time. This is arguably one of the most important labs, hands down. Um, Security for your applications is an um, increasingly in high demand in the world of web application development and just in the general world of software development. Now the reason this should be pretty obvious. There's a security attack that compromises the data of your users or that compromises the integrity of your product can mean that your company will lose value very, very fast, right? If you leak users' data, you might get sued. And oftentimes, something that seems innocuous can actually be far more dangerous than it is. So, today we are going to talk about two primary types of attacks that occur on web applications. I'm going to show you examples. Um, and then I'm going to give you a little bit of some information on how you prevent these things from happening, and also show you another demo of an application we did earlier in the class. So to start with, the first attack we're observing is called a cross-site scripting attack. Now, I haven't read this wiki page, but essentially what cross-site scripting is that you embed JavaScript code into the application through one of its inputs or forms. So if you think about it, right, like if we were to do an inspect on a website, right, if there were some way as the user specifying inputs, let me make this bigger. There are some way as the user that I could, in theory, do this, right? Or not add attribute, but edit as HTML. If I could do something like script alert hello, right? Just I'm embedding JavaScript in here. If I could somehow achieve this, but through the application, right? Because you can't actually edit the page that other users will see. And then I could compromise this application and I could run my own code on someone else's website. So this here, I clicked on this link for the cross-site scripting game. Now there's a lot of tools out there for people who are aspiring hackers, white hat hackers usually. So there's black hat and white hat. White hat are people who they hack systems in order to figure out how to defend them in order to prevent bad things from happening. Black hat are people who do so for profit or infamy or whatever motivations they have, right? Or nation states and whatever. So here's an example. So we have this website, 4or4. Okay, so it's got a query. So if we search no results for hello. So here we can see the code. This isn't PHP, I don't think. I have no idea what language this is. It could very well, it's a Python. Okay, it's Python. So anyways, somewhere down here they're appending this query between these tags. So let's try this again. So let's say that we do this. So instead of typing a regular query like hello, we're going to surround it in tags, right? So it's a header, right? And when I click search, if you look, now we've got kind of this giant hello on a new line. So that's kind of interesting, right? Why is this happening? So here we go. And it does italics if we do italics. So if we inspect, I think this is going to be a little frame in here, okay? So if we look inside this, no results were found for, and then we have this, and then see how our tag is registering as an actual tag in there, right? So we can embed a tag into this website. So what does that mean? That means that what happens if we were to do this? Script alert hello. So now I'm embedding some JavaScript. Oh, so now I just got a hello alert, right? So I can actually essentially hack this website, right? So I have a script tag now. Let's say what would be something funny to do? So if we do this, right, we get this alert, right? So what if we look at our page right now, our iframe, document. So it's got a header, which is a logo. It's got a div. So what if we were to append something? So if we were to do script, I don't know if they're using jQuery, so we'd have to do it document.get element by ID. Oh, what was that thing called? Oh no, I have to retype it now. Okay, so what we're doing is script, and then we're actually embedding something more consequential than just JavaScript code. Document.get element by ID level 1. Let's see if this works. Yeah, we appended this hello text to the body. So now if we look here, sorry, this is confusing because there's an actual HTML document within an HTML document. So we have our body, right? And then we appended just some random text to it. So what I'm saying is that we kind of have free reign over this website if we can inject JavaScript into it, right? Because in theory, I could just copy and paste some JavaScript code into that input. And like maybe I'm going to use it to go to a different website and pull some resources, or maybe I'm going to use it as a bot to attack someone else's website with a denial of service attack, right? I can do that because I'm able to write code onto this website that they weren't intending for me to write, right? So that's what a cross-site scripting attack is. So you can read about this. I think this is a worm that someone created, so they used a cross-site scripting attack to kind of deploy this worm. But for now, we're going to move on to SQL injection, which I think is, which is also extremely interesting. So, is there a way I can? So you should definitely walk through this because this is interesting. So, let's go ahead and do this. We'll follow these instructions. Username at email.com. So this is a vulnerable, quote-unquote vulnerable website they've created, right? And here are the logs of the SQL server. So I couldn't find the user in the database, whatever. So now it's saying type password, but with a single quote at the end. So we type that, and you can see there's a failure. So if you look in here, we have select star from users where email is username and password is equal to password or whatever, right? So they're taking whatever we put in here and they're sticking it in the query to figure out who the user is. Okay. So how does this make this website vulnerable? Well, they're actually going to show us, right? So here's what the SQL query looks like, right? We did some SQL in a few labs. So we've got select star from users where email is the email they put in and password is the password they put in, right? So now they're going to show us how to hack this. Password, quote, and so now look, so we've essentially unquoted and now there's just hanging quote, which causes that error, right? So what if we were smart enough that we could manipulate this query? So what they'll have us do is instead of typing a password here, we're going to type quote. So see how it cancels this quote, or 1 equals 1, and then I got a space, well, or 1 equals 1, comment, and I have to do a quote there. Gosh dang it. Okay, quote, or 1 equals 1. So what's happening is password equals empty string, or 1 is equal to 1. So 1 is always equal to 1. So this query will always resolve true. So what will happen is it's going to grab the first entry in the database and it's going to log us in. And these double slashes like this comment out anything afterwards. So essentially we're cutting off the query right here and we're basically setting the result of this query to true. So now if we do this, we're able to log into the account even though we don't know the password. Okay, so now we can, steal this person's money. So it's you can definitely go through and play through. If you look at SQL injection games, there will be some. And it's a good way to practice. But essentially, what's happening is they are adding their own SQL code into your application, because what's happening is you're taking user input and you're stuffing it directly into a SQL query. Now, if they're smart enough to know what your query might look like, they can take advantage of that to basically run queries on your database without your permission, which means they can drop your tables, they can alter your users, they can steal passwords, right? This happens all the time. It is one of the most frequent types of attacks that occurs on websites. And it's super, super dangerous, because imagine you have a database of passwords and usernames, and someone uses SQL injection and they get everyone's username and password and identity. And maybe they don't use it on your website, but they know, okay, everyone usually uses the same password. So even if you're a little rinky-dink website that's doing online shopping or something, and they get the username and password of your 500 users, even if they don't use that on your website, they might be able to derive, okay, well, they probably use the same email and password on Facebook, so now I can get on their Facebook, or, oh, now I can get into their bank account, because people, believe it or not, will use the same password on their bank account as well. So that's why they always say never use the same password for everything, because if someone steals one password, then they can use it to log in at all these other sites, and you wouldn't believe how vulnerable so many websites are. So this is why it's your responsibility as someone who's building websites to not be one of those websites, to not be one of those vulnerabilities that hackers can take advantage of. It's kind of like a civic duty of the web development world. So how do you become a website that's not vulnerable? The key, all times, anytime there's input, sanitize your input. So what does sanitizing input means? Fuel will usually do this for you, but it means, okay, make sure that there's no JavaScript tags. If it's SQL, make sure there's nothing that looks like a SQL query in there. If it's a file upload, that's what people don't realize. File uploads, for example, that's something people can manipulate, right? They can put like SQL code in the file, and then if you read from the file and you do stuff with it, they can attack you from there. Or if you even have a get variable or a post variable and you don't sanitize the input, they don't have to attack you through the website. They can use, the terminal to send code to your application. So you always, always, always have to sanitize your input. Anytime someone else is putting input into your application, or even when you're reading from a file you think you trust, you should probably be sanitizing it and making sure that it doesn't contain anything that could damage your application. So for those people who have XKCD or like XKCD, this is a pretty good comic. So it's like, essentially she's calling in, right, and like basically asking the mom, like, hey, we're having computer trouble, like, what happened? And they're like, did you really name your son Robert, quote, close parentheses, comma, drop table students, and then like essentially the starting comment tag, right? So they call him Bobby Tables, and it essentially is what happened to this school is they named their son this really unusual string of text, which causes the school, when they enter it into their database, to drop all the tables, right? To drop the students' tables, and they lose their database input. And so the joke is that I hope you learn to sanitize your inputs, right? So it's funny because you're like, okay, no one would ever name their child that, right? But the joke is that we make certain assumptions about the data that we are getting, right? That we're getting data that we trust. People will never name their students something that can harm their system. People will never upload a file that'll harm our system, right? Even if like, oh, it's only a workspace website and our employees are never going to attack our own website, right? It's like something like 50 to 70% of cyber attacks occur from within a company, right? From their insider attacks. So you have to protect against everything. So Fuel can help us because they have this security class, right? And the security class, output encoding, CSRF protection, which is something I think we talked about before, input filtering, SQL injection. So here they have an input filter option in security. And so when you get input from the user, Fuel automatically will get rid of these tags and stuff. So remember we did that to do app like a long time ago. Let's see if we can even get to it though. CS call state /CT310 year 2020. Now let's go all the way down to, I think it was model view controller, to do app. Okay. Where is the example? So I think it's going to be under recitations, resource site, to do example. I'm going to have to open up code to see where I put this. So if we look at, you're seeing the back end of the CT310 website right now. So congratulations, secret look. Hopefully no one on YouTube destroys our website as a result of this. App classes, controller, to-do, DB. Let's see if I have one on. I'm gonna have to. Dang, I thought we had an example for this, right? I guess we didn't. Okay, well, anyways, in that to-do app that we built earlier in the semester, right, the one where you guys had to add your own stuff to it, it was automatically filtering input. And if you remember, there was a class that I lectured for where Ben wasn't there. And at the end of the class, I was telling people why one of the reasons fuel is useful is to prevent these types of cross-site scripting attacks. And then I tried to do one on the website, and it didn't work. And it was because it was a fuel website. So here's what I'm going to do. I'm going to show you guys an example. So what we'll do is I'm just going to go ahead and copy this link address. And I'm SSH into my lab machine right now. And I'm just going to do this on public HTML because I'm not in the VPN. And I'm going to download this example code. I'm going to untar it. So now I've got this, this stuff here. And then I'm going to go to my home directory and chmod 755-r public HTML. So I'm doing this in public HTML, and I just downloaded that application is all I'm doing. So if we change to examples, okay. So now let's refresh my CyberDuck. Let's close out of this. Let's look at this code. So let's go ahead and go to my website, and we'll go to examples/to-do vulnerable PHP. Undefined variable to do. Ooh, saucy. Well, line 38. We'll see what's going on. I think that was the error. So let's reload this page. Yeah, just somehow this thing got named something wrong. Okay, so here's the to-do app, right, without fuel. And obviously, look, it looks pretty simple, right? So we can go to the store and add something to this list. Say. So this is a pretty straightforward app, right? So we've got two forms. We've got the input and the delete form. The delete one doesn't work, it seems like. So I don't know what's up with that. Okay. And then here's all the PHP code that's behind it. So we have a get to-dos from file, so it uses just pure PHP to open a file, read it, and then basically trim the strings, add them to the array, whatever. Add to-dos. Basically, I took all the model code from that example we did earlier, and I kind of just copy and pasted it in here. And I have some code. Basically, if post, so what happens is every time this website gets run, it loads these functions, and then it checks if the to-do text is set, and then it adds a to-do, and then it gets all the to-dos from the file, and it gets the count of them. So then what it does is it iterates through all our to-dos and updates the page with them. Okay, cool. So here's what's interesting is this is vulnerable to cross-site scripting. So if I do this, you can see, oh, we got an alert, right? So now if I go and look in my the data file, you can see this is in the data file. So it's very funny because now even if I add something else, get milk from the grocery store, when I post this, it's going to reload the page and that alert's going to happen again. So now that is basically, that is embedded in this website. So if we do an inspect, you can see that this list is an empty list element with a script tag in it. And that script tag is just an alert, and then there's another list element. So it's kind of crazy because this is input's not being sanitized. Now if I had the other app running, which I don't right now, what you would see is I would type script like this, and it would just appear as, honestly, it's probably worth it. Let me just go VPN. And I gotta find my phone though, so we can access the VPN. All right, VPNing, logging in, should approve me here in a second. And there we go. So now we've got our VPN, we're logged in. Let's go to, let's figure out if I have the to-do app hosted on my thing. So let's look in my Fuel app controller, classes controllers, and we have to-do. Okay, so let's do this. Let's go to, well, we're already pretty much halfway there, so 444 ct310/index/to-do. Sick. Here we go. So I was trying to do this earlier, so I'll show you. So this is the app that's built with Fuel. So the other one, right? So here's our vulnerable one. You can see the script pops up. Here's our non-vulnerable one. So if we post this, here's the debug. Fuel sees the string as this, and it writes it back out like a normal string. So it escapes this script tag. And if you look in the HTML, look, it's just normal text. It doesn't actually interpret it as a tag. So it's pretty sick because now you're basically, okay, hack away, try and embed my website with these scripts. It's not going to work because Fuel's in the back end protecting me, making sure that you're not hacking my website. So that's one of my favorite things about Fuel. That is one of the things where it's like, okay, this is pretty sick. This helps out a lot. Versus, you know, if you try and roll your own website, yeah. And I mean, like, it's true. Like, if you look at this, like, it seems pretty straightforward, but it's going to get messy really fast when you have more than one input form and you have all this stuff going on. Fuel allows you to modularize and it keeps you secure. So at first it seems really heavyweight, but really it's giving you all these benefits that you don't realize at first. So my hope with this lab was that you all had an opportunity to kind of get an intro into security, right? Let's see if there's a famous SQL injection. So these happen all the time, right? Sony took one. Exploitability. Okay, let's look at this Sony attack. Does anyone remember the accessed Sony pictures and got millions of user detail, passwords, home address, and personal information through SQL injection? So what's interesting, right, is these happen to big companies all the time because there's some dude who's an intern or some dude who, you know, from 40 years ago didn't think about security when he built the application. It's very hard to go back and build security in, right? So, like, if this was my application, and you would not believe how many companies have applications like this that are vanilla, now I got to go in and go, okay, in my get to-dos from file for each to-do, or, you know, in my post, when I get new text, you know, I got to write some custom code that's going to try and stop a SQL injection. That's going to try and stop this scripting. And the issue is that you're probably going to do it wrong because it's very difficult to do and because hackers are very clever. So that's why Fuel is good, because it gets vetted and they test it and stuff like that. So my hope is that you got an intuition of most people, like if you haven't taken CS 356 yet, which is the security course, or you might never take it, you might not consider security very often, but it's oftentimes one of the most important requirements of your application. And so if you want to play around with it more, if you start getting interested in security because of this, um, you can join Hack the Box, and you can do what's called penetration testing, so you can try and hack their websites. You can look at SQL injection, cross-site scripting games. I'm going to drop you all a tip if you do play with Hack the Box because you want to get into cybersecurity. Um, in order to join, first of all, in order to join, you actually have to hack their website. So I'm gonna let you know that. It is kind of a slightly complicated attack, but it's not overly complicated, and it's something you could figure out if you did a little research. There's also tutorials out there on how to do it, but there is no way to register, you can see. So just so you know, Hack the Box, you actually have to hack to become a user, so it's kind of funny. But anyways, thank you for watching another one of my labs, and this lab's not going to have anything to turn in, so there won't be a lab 17. You'll get credit, or I guess credit by default. But I just appreciate you guys watching the labs. I hope you're all staying safe, and I hope you're doing okay. As your TA, I'm here for you if you need something, if you don't feel comfortable going to bed, or if you're going through a lot, if you're feeling sick, or if you have issues with family, or if you're feeling alone because you're trapped inside, because I know I'm starting to feel alone from being trapped inside, you can DM me on Slack or send me an email or just reach out to me, and I will be here for you. And as your TA, like I appreciate all you guys being here in class, and I appreciate having you as students, and I wouldn't want anything to happen to you guys, and I wouldn't want you guys to be dealing with mental health stuff on your own, or struggling on your own, when I'm here, and I'm willing to help you. So, just stay safe, reach out to me if you need me, and try and have as much fun as you can while being trapped inside. So I will talk to you guys next week when we do our design lab, but for now, I hope you guys have a good week.